Hello, my name is Julian Osgood, and together with Emmanuel Hervy, today we would like to present to the IULTCS Congress Unhairing System Comparisons. Today we would like to compare a traditional hair burn process using sodium sulphide against a zero sulphide process that we have developed. Unhairing principles, traditional hair removal process. In the conventional liming hair burn process, the liming chemicals either destroy the hair and epidermis completely, or they loosen them to such an extent that they can be removed mechanically. This process traditionally uses around 1.5% to 3% of sodium sulphide and sodium hydrosulfide. Compare this to the hair saving process. The hair save process uses the same chemicals as the hair burning system, that's lime and sulphide, but we apply them differently. The principle of the method is the hair fibre is firstly partially protected by lime and then enzymes added with a low or even a no sulphide process to attack the hair roots, thus allowing the hair to be removed by a filtration and collection process. This process can use zero sulphide, or if a part process is used, up to 1% sulphide. What are the advantages of using a hair saving process? Firstly, a lower TDS, a lower total dissolved solid content of the effluent. With this, you have a high volume of solid waste suitable for processing into saleable byproducts. By this we mean the hair is actually collected during the process rather than being dissolved into the effluent and needing further effluent treatment processes. Because of this, we get a much lower BOD and COD and nitrogen content within the effluent. This gives us lower hazardous and unpleasant air emissions within the beamhouse processes, and a reduction in effluent treatment costs. Together with this, we have a reduced sludge disposal costs, reduced sulphide consumption, and therefore reduced hazardous chemicals within the tannery. Let's take a look at the zero sulphide process formulation. We start with a 150% float and a small amount of soaking agent, very typical. Run for a couple of hours, drain, a slightly shorter float for the next process with soaking agents, degreasing agents, emulsifiers and some small amount of bactericide. Run that for 90 minutes and then leave overnight. After draining in the morning, an even shorter float is used for the first part of the unhairing process, where we introduce chemical A. The characteristics of this chemical we're going to discuss shortly. We also add a small amount of lime and we run for an hour. After this, chemical B and C are added and the filtration process is run. In the laboratory scale trials that we did early on, we just used a simple fishing net to fish out the hair from the process at this time. But in production scenario, a installed filtration system could be used at this time. After all the hair has been removed, we add a little bit more water, some more lime, run for 20 minutes and again leave overnight. Draining this the next day, we add another float of 150% water, some degreasing agent, run for an hour, drain and flesh the leathers after unloading the drums. The key points of a zero sulphide process, things that we really have to get right to make the process work. In our experience, perfect wetting back is extremely important. Also, the use of short floats is highly recommended to give enough mechanical action to the process and to use high enzyme concentrations of the products. We need a good immunization of the hairs, a good protection of the hairs, and we need to control the swelling of the hides not too much and not too little, for the process to work very efficiently. The Zero Sulphide Process key products include Chemical A. The characteristics of this product are that it improves lime solubility, it reduces excess swelling, reduces wrinkles on the hides, and it increases the total area of the hides. It gives soft and fine grain. Chemical B is an unhairing enzyme which acts at a high pH, and it's designed to attack the hair keratin. Chemical C is an inorganic sulfide-free ecological unhairing agent. It also reduces wrinkles on the hides and improves grain smoothness. This photograph has been taken round about 1 or 1.5 hours into the unhairing part of the hair saving process. These 3 photographs show the unhairing process after running overnight. It's clearly visible from the photographs how the hair remains intact and should be easily removable by a filtration system. Please also note the colour of the float that remains in the liquor. It's much lighter and less contaminated by what would be dissolved hair in a traditional hair burn process. I would like to now show you a short video that Emmanuel and I made as a side-by-side comparison between a sulphide traditional system, hair burn system, and our ZSP system. These two photographs were taken after the process had been running for 2 hours. On the left we see the traditional sulphide hair dissolve system, and on the right the hair saving system. Look at the differences between the two floats. This photograph clearly shows the two hides after the processes. On the left, the traditional hair dissolve method, much darker and more wrinkled than the hide on the right, showing the zero hair sulphide process, which is much smoother and much lighter in colour. This photograph shows the final floats of each process, and I think is fairly self-explanatory. Float samples were analysed from each process, and here are the results. You can see that with the ZSP system we experienced a total dissolved solids of -41%, COD was down to -47%, BOD -14%, and the ratio between the two, BOD-COD, -37%. And the sulphide found within the two processes, 110 compared to 0.8 milligrams per litre with the ZSP system. Significant improvement. One of the problems with the system, of course, is removing the hair. This would need a significant investment from the tannery for each drum to be used, and a system something like this could be set up. These photographs show float collecting gutters installed onto drums and hair filtration and collection systems that can be used. I hope you agree that this is a very interesting subject, and should you have any questions, please address them to myself or Emmanuel, or feel free to contact us directly at any time in the future should you need any more information about our project. Thank you very much.